Astronomers may have just found the most disturbing planet ever seen, because this one isn't orbiting its star. It's dying in front of us. The planet is called BD+05 4868AB, and behind it stretches a tail of rock roughly 5.6 million miles long, like a cosmic wound dragged through space. We are not looking at a stable world. We are catching a planet evaporating grain by grain. That's the what. A small, scorched planet orbiting so close to its star that its own surface is turning into dust. The how is even harsher. Every orbit, heat blasts minerals off the planet, and radiation pressure pushes that material into a giant tail, like a comet made of broken crust instead of ice.
And the reason this matters right now is simple. We're no longer just finding exoplanets as neat dots on a chart. We're starting to witness their endings. Personally, that changes the feeling of astronomy for me. It stops being a catalog of worlds and becomes something closer to an obituary, written in starlight. Let's start small, not with the whole planet, with a single grain. A grain of mineral dust lifts off the day side of this world. The surface may be hot enough to melt rock, likely above 1500 to 2000 Kelvin in these extreme ultra-short period systems. That grain escapes the crust, enters a thin outflow, and gets shoved backward by the star's light. One grain becomes a stream. The stream becomes a tail. And the tail becomes evidence. Evidence that the planet is literally being stripped apart. This is a classic zoom-out story in reverse emotion. You begin with a speck of dust, and a moment later, you realize that speck is part of a dying world. Oh. Can you imagine standing on a planet where the ground beneath you is not solid history, but material already on its way to space? Astronomers have seen hints of disintegrating planets before. Kepler 1520b became one of the best known examples after NASA's Kepler mission found strange, variable dips in starlight. In 2012, Saul Rappaport and colleagues argued in the Astrophysical Journal that the changing transit depths could be explained by a trailing dust cloud from a rocky planet losing mass. That idea mattered because it turned a weird light curve into a physical story. Not just a planet crossing a star, but a planet coming apart. BD+05 4868BA pushes that story into something even more visceral. Reports describe a tail about 5.6 million miles long, around 9 million kilometers. For scale, that's more than 20 times Earth's diameter. It's a planetary afterimage stretched across space. And when I first sat with that number, honestly, it didn't feel scientific at all. It felt tragic. But there's a mystery hidden inside the spectacle. If planets are dying like this, why don't we see them everywhere? The answer is brutal. We're probably catching them during a very short final phase. A blink, a last exhale. That is why now matters. Missions like Kepler first taught us how common close-in planets can be. TESS, launched by NASA in 2018, widened the search across nearly the whole sky. Newer surveys are getting better at spotting odd, asymmetric transit signals, the kind a dust tail can create. So this discovery arrives at a moment when exoplanet science is shifting from census to behavior. Not just what worlds exist, but what worlds become. hum under pressure. If you had to choose, what's more unsettling? A planet freezing forever in darkness? Or a planet slowly blowing itself into space, like this one? Tell me in the comments. I really want to know which fate feels worse to you. The mechanics are extraordinary. This planet likely whips around its star in only a few hours, putting it in the category of ultra-short period worlds. At that distance, the star dominates everything. The day side can become an exposed furnace. Minerals such as silicates may vaporize, then condense as the material flows outward and cools. That creates dusty debris capable of blocking starlight in irregular ways. Instead of a clean dip, you get an uneven signature with a leading or trailing asymmetry, a fingerprint of destruction. And there's another reason astronomers care. Dust is not random decoration. Its size, composition, and survival time can reveal the planet's surface chemistry and the violence of the environment around it. In 2015, research led by Brian Jackson modeled how dusty tails from disintegrating rocky exoplanets could constrain mineral composition and mass loss rates. So the tail is not only a symptom, it's a sample of the planet's body spread out where telescopes can study it. A shredded world is, in a strange way, easier to read. That may be the deepest part of this story. Death is making the planet legible. We understand it because it is failing. Mini Hawk. But the most unsettling part is not the tail length. It's the clock hidden behind it. Astronomers estimate that some disintegrating planets could lose enough material to vanish on relatively short cosmic timescales. Sometimes millions of years, not billions. That sounds huge in human terms?
In planetary terms, it's alarmingly fast. Compress Earth's 4.5 billion year history into a single calendar year, and a destruction phase lasting 10 million years would be little more than a day. A world can spend eons forming, then spend its final chapter unraveling almost instantly. And this is where the story stops being just exotic astronomy. It becomes an existential time lapse. We tend to think of planets as the durable things. Civilizations collapse, species vanish, people disappear. But planets feel permanent. BD+054868AB is a reminder that permanence in the universe is often just slowness beyond our usual scale. Do you ever wonder how many things look eternal only because we're too brief to watch them die? But wait, there's something even stranger. This planet may be more useful to science because it is dying than it ever was while intact. A normal rocky exoplanet is usually a dark silhouette. This one is spilling its interior into space. That means astronomers may be able to infer what kinds of rock it contains, how strongly its gravity holds material, and how stellar radiation sculpts the debris. In other words, we may be watching geology happen without landing there. Confession, that blows my mind a little. We spend decades dreaming of touching alien worlds, and then the universe hands us one that is already turning itself inside out for inspection. There's also a broader warning here. Close to a star, being a planet is not enough. Mass matters. Gravity matters. Composition matters. A world just slightly too small, slightly too close, or slightly too fragile can cross an invisible line where surface becomes atmosphere
atmosphere becomes tail, and tail becomes absence. The difference between a planet and a debris stream may be smaller than we wanted to believe. Mini-hook, and what scientists discover next could change how we define a planet's lifetime. Tense. In my view, BD+054868AB matters more than many larger, prettier exoplanets, for one reason. It restores time to the picture. Too often we talk about planets as static categories: rocky, gaseous, habitable, uninhabitable. But worlds are events, processes, temporary arrangements of heat, chemistry, and gravity. This object makes that impossible to ignore. And yes, there is something almost unfair about it. Humanity arrives late, builds sensitive enough instruments, and just happens to catch a planet near its end. What are the odds? Already low. Yet here we are, looking across space at a body that seems to have survived its birth, its collisions, its migrations perhaps, only to be erased by the star it could never escape. Does that make the universe feel colder to you? Or more precious? Mini-hook, because the final payoff is not about that planet alone. It's about us. If this idea hit you the way it hit me, that we're watching an actual planet die in real time, leave a like. Not for the algorithm alone, but because this is one of those discoveries that deserves to be remembered. We live on a world that feels solid under our feet. Mountains look ancient, continents look patient, oceans seem endless. Yet the universe keeps whispering the same lesson in different forms. Stars die, moons break, atmospheres vanish. And apparently, planets can trail themselves into nothingness. BD+054868AB is not frightening because it is bizarre. It is frightening because it is honest. It shows that a planet is not a monument. It is a negotiation between gravity and heat, between structure and escape, between how tightly matter holds on and how hard the cosmos pulls it apart. And for this world, that negotiation is ending badly. So the next time you hear the word exoplanet, don't picture a tidy sphere hanging motionless in a textbook. Picture motion, pressure, loss. Picture a world leaving a tail of powdered rock 5.6 million miles long as it circles the star that is undoing it. Picture the universe, not as a museum, but as a place where even planets are temporary. And maybe that is the real payoff, not despair. Perspective. Because if even planets are fleeting, then every stable horizon is rarer than it looks. Every long-lived world is a kind of miracle. Personally, I find that unsettling. I also find it beautiful. BD+054868AB is falling apart grain by grain. And across that impossible distance, for a brief moment, we are here to see it. If cosmic stories like this expand your sense of how fragile and strange the universe really is, subscribe and stay with us. There are many more worlds out there, and some of them are already telling us how they end.